let's first do a quick factor tree. Right? So 60 is 2 times 30. 30 is 2 times 15. 15 is 5 times 3. Right? So there's all our prime factors. As we can see, we only have one pair of prime factors. So that pair is the only pair that comes out. So what we can now say is that this expression here is equal to 2 times the square root of 15 plus 2 times the square root. And this is very, very straightforward. If you really think of 15 as being x, or the square root of 15 being x, then you've got 2x plus 2x, which is equal to 4x. So what that tells us is that 2 times the square root of 15 plus 2 times the square root of 15 is just equal to 4 times the square root of 15. Okay, so the operation in this particular one is division. And as we learned before, we learned that if you have a radical with a fraction inside, you can break that up as being the square root of the numerator over the square root of the denominator. So, in this case, we're going to do that right away because that is definitely going to help us. So that is equal to the square root of 28 over the square root of 45. Now, from here, with division, we're really going to be looking at canceling out problems. That's kind of what you're looking at, the numerator and the denominator, and what roots, what terms actually cancel out from here. And in order to do that, we need to simplify both of the square roots. So again, let's go back to our factor trees. 28 is 2 times 14. 14 is 2 times 7. All of those are prime. 2's are a pair, so that's going to be equal to the 2 times square root of 7. 45 is 5 times 9, and 9 is 3 times 3. 3 is a pair, and we get 3 over root 5. Okay, this is as simple as we can do it. There's nothing that we can cancel out from here, but this is all we can do to simplify it. 2 root 7 over 3 root 5. Now, just a point to note, Khan Academy, when you click on the answer box in Khan Academy, it is going to give you a drop-down menu of various different functions you can choose. Make sure that you are choosing the fraction function first, and then in each of the boxes, put in your number first, followed by choosing the square root button, which is the square root of x. And when you put that in, put in your square root of 7. And on the bottom, you're going to put in 3 root 5. Okay, so make sure that you're using that drop-down menu to put that in. Okay, let's take a look at when we got negative numbers in our addition problems. Again, this is really no different. Just watch out for the negative. We need to simplify each of these terms. First of all, let's start with the 40, and then we'll do the 90 in blue. These are different terms, so you've got to do both of them, not just one of them, and that applies to each. And that's really the difference from the first problem we did in this set. 40, of course, right, this square root of 40 is going to be negative, whatever you get at the end. So 40 is 2 times 20, 2 times 10, 2 times 5. Okay, so 40 is 2 times 2 times 2 times 5, and we can pull out a pair of 2's, so that's going to be equal to 2 times the root of 10. Just to clarify here, this 2 and this 5, they have to go back into the radical because there isn't a pair to go with them, so you multiply them together to do that. Okay, so don't forget your negative sign. and our positive sign here. 90 is then, well, let's simplify this. Let's go straight for the 9 times 10. We know from here that 10 is 2 times 5, so let's not bother taking it out unless we need to. And this becomes 3 times 3. You don't see any of the 2's in there. You don't see a 5 in there. So we're just going to leave the 10 where it is, make our life a little bit simpler and quicker. But for if you want it to be complete and if you want it to be thorough, make sure you take out the 2 and the 5, and then put it right back in because you don't have anything to pair up with. But these 3's pair up so that 3 comes on the outside, and the 2 times 5 goes on the inside, and it's 3 root 10. Okay, so the question here again, remember this is negative 2 times the square root of 10 plus 3 times the square root of 10. It's like taking negative 2x plus 3x. Negative 2 plus 3 is, of course, positive 1. So our answer here is going to be 1 times the root of 10, or just simply the root of 10. That will work for you as well. So just the root of 10 will work because 1 times anything is just itself.
Okay, so the square root of 242 over the square root of 2 is quite an elegant problem. Of course, if it was written as the square root of the fraction 242 over 2, we could divide 242 by 2 at the beginning and just get 121. Knowing that the square root of 121 is 11, we would be done with our problem. But for a little bit of practice, why not actually do the math that we've been practicing doing in this particular situation, and do our factor trees. So the square root of 242 over 2, let's start with 242. That, of course, is 2 times 121, and 121 is 11 times 11. So square root of 242 is 11 times the square root of 2. And just to illustrate the point here, when we put that fraction together, nothing we can do with the square root of 2, so we put it back in here. And what I was talking about earlier about the cancelling out of the common terms in a fraction, you have the square root of 2 divided by the square root of 2, which of course is 1. So we're left with just 11 in the numerator and 1 in the denominator. So our answer is 11. Quite an elegant problem.